Nice. Well, we want to welcome everyone for another coffee session. I have the pleasure of recording with Demetrius again. He's one of my favorite people to talk to. He's my boy. But we have a really interesting conversation, and it's going to revolve around this article that came out recently by Google, and it's titled MLOps: Continuous Delivery and Automation Pipelines and Machine Learning. And we're going to talk about a lot of cool concepts. For example, in the article, they talk about DevOps versus MLOps. Now, I know we've kind of talked about that in the past, but I'm not going to really focus on some of the prior conversations, just kind of inform that. Another key component is they talk about the data science steps for machine learning. So they outline what they believe is the typical ML workflow or data science workflow. And then they get into these levels of pipeline maturity. And today's session, we're going to only cover some of the first points. We're going to break this up into another one, and so you'll be hearing more about this. But at a high level, what we want to do is we want to think about this ML pipeline and some interesting views from big companies like Google and how they view this ML pipeline, how they view MLOps, and also some not, maybe criticisms is not the right word, Demetrius, right? It's like more like just another
things to
point
keep
to
in
consider.
mind.
Yeah, things to keep in mind. And yeah, Demetrius, anything else you want to add to that?
Yeah, I got my tea. I know it's called coffee sessions. I see you there with the coffee, so at least somebody has that holding it down.
Yeah.
I'm in my cup of gratitude. Thankful for this coffee session right now.
I'm sure you hear there's some funk in the background.
You all don't know how long it took us to figure out how to make it.
Oh my gosh, yeah. You would think, as people in the tech industry, that we would know how to work this, but no. We spent like a half hour, 45 minutes?
45 minutes. We're just getting started right now. We're supposed to start at 6, and it's 6:45 right now.
It's all good. It's always a pleasure with you anyway, so we're having some fun anyway.
And success. We got it working, so let's go ahead and get started. So break it down for us, man. Break down like the idea of automation and this continuous delivery for machine learning, because I know that is something that we've talked about on the show before. We had Elle on, and she was talking about CML, and it's something that I think people jump to right away. They think, oh yeah, we should do it like that because it'll make life easier. But sometimes it doesn't really make life easier. And so give us a little bit of background on that.
Yeah, so I think, even before we kind of get into, just automation and what it is or things like that, it's, after reading this article, me and Demetrius really kind of got this sense or this feel about it that, one, that Google is definitely trying to be a leader in this field. They're definitely trying to, set precedent for what MLOps is and how it works, or, what are some best practices in that. But a key component of how they view it is, a big part of what they're trying to do with MLOps is to automate a lot of things, if not everything. And so a big part of, or a presupposition, I guess is one way to frame it, is that they believe that practicing MLOps means that you actually advocate for more automation, but not only automation, but more things like monitoring. And you want to do this at all steps of the ML system pipeline, right? You want to do that, the construction of it as you're building it, as you're thinking about integrating it into other things, as you think about testing it, releasing it, deploying it, and then managing all of that. A key part of what they think is a good best practice is actually automating everything. And so with that in mind, we want to just, before we even get into, talking about the article, like, is automating everything good or bad? And there's also been some chats about this in the past. So Demetrius, maybe you can kind of remind us on where we've discussed this before.
Well, yeah, in the meetups, we had 2 great talks about this. I think the first one was a very opinionated Charles Martin, and we'll link to that in the show notes if you want to check it out. His whole vibe on it was, why do you need to automate it? What is the point of automating it? And really, like, is it going to make your life that much easier, especially in the beginning? So he was very much in the camp of, let's figure out a business case for this. Let's make sure it works. Let's get it out manually and handhold it all the way through. And then once we know that, all right, everything's good, it's working, it's all good, and we've gone through it various times and it's starting to become a pain, then you automate it. But if it's just like automation for automation's sake, he's very against that. The other one that I wanted to reference was Phil Winder. And this was like one of the first MLOps meetups. We'll also throw a link to that in the chat, or in the show notes, but he was talking about how he has like his MLOps hierarchy of needs, right? And you can kind of imagine like the pyramid. And I haven't looked at Maslow's hierarchy of needs in a while, so I can't remember what is like at the base, but I
It's
think
like
I've,
things for survival, like, you know, that are core, like essential literally
yeah,
to like live, you know?
food, water, shelter, that kind of stuff was at the base. And so for Phil, um, his whole thing was that automation should be at the top. Like with Maslow's hierarchy of needs, I think it's like the search for.
Just found it right now. So there's the top one is self-actualization,
There
and the
you go.
bottom one is physiological needs. So like the basic things you need for, you know, your system to run,
So
versus self-actualization. Go ahead. Sorry.
yeah, self-actualization would be, in his eyes, that's the automation. And the automation does not need to be like the base and the foundation that you're running off of. And so I think that the Google paper talks about this kind of like in the maturity levels. And they say like, you know, if you're at maturity 1 or 0, you're just doing everything by hand, and then you have some automation, and then it's fully automated. But it never says like, because automatically when you look at that, you think, okay, my maturity is 0. That's not good. But
Yeah, exactly.
it
That's the
shouldn't be
first
like
impression
that.
that. Yeah, I think you know, after you know, kind of having these conversations, even in my own work, that's often a question or criticism that comes up is that point exactly. You know, like it doesn't incorporate some of these other use cases, these nuances, and yeah. So yeah, I would love to kind of dive more into that.
Yeah, so that was the first thing. And I just realized that you changed your name earlier to MLOps Bam Bam, and you changed it back. What happened?
I don't know. Like, it got taken off. We need to fix this real quick. For those of you, I guess not embarrassing at all, but my family has a nickname for me, Bam Bam, because I'm
So MLOps Bam Bam, dropping the
MLOps
knowledge.
Bam Bam.
Let's talk about this. Besides, like getting too far off track with Mr. Bam Bam, let's talk about this a little more, and like why we feel that automation is just like a necessity always, right?
Yeah,
Like
yeah. Where does that
there.
come from? You know, that's
Exactly. And I think that's something that we referenced earlier, how Google is very much like an engineering culture. And
yeah,
I don't personally know, I never worked at Google, but people that have told us, and kind of the way that they present themselves to the outside, is they're very much like that engineering culture. And so it makes
yeah.
sense that they're trying to automate everything, even if it's not an engineering problem per se.
Yeah, yeah. I think it's fair to say, like, you know, you just kind of reading what they put out there, right? What this is their research articles or what they put on Google Cloud with their solutions and kind of their overview of things. I get this sense that, you know, what they're really trying to do is maximize the velocity that your software is actually delivered, and that those components of it, you know, every part of that is maintainable, right? That it's extensible, that you can change it, it could evolve, and that it's testable. You know, you could verify the correctness of the system or whether or not it's doing what it needs to do. And if that's like what you're trying to do, then it makes sense, right? You know, it makes sense for you to look at, you know, the machine learning system or pipeline through that lens of, we need to get this out as quickly as possible and be able to change things and get it as quickly out as possible. But I don't think it's fair to say that's all they care about, because, you know, one thing that I was in this article, and they mention is that they still view the machine learning solution lifecycle as still largely experimental. And I think that's very important to keep in mind. And that's actually what Charles Martin was kind of getting at, is that we're still researching, you know, and it's not always necessary to productionize all ideas. And I feel like Google could understand this, right? There's a lot of ideas that they put out there that actually never worked, right? I can't think of one, but I know there's been some failed instances. And
Google Glass.
And yeah, Google Glass is one, right? And you know, it's because they can afford to try those things out, so they don't productionize everything themselves, right? But you know, I think that, you know, like you mentioned at the beginning, is that when you first start like reading these things and you hear about what, you know, these big companies are doing, you kind of feel like if you don't have what they have, that you don't have a production ready system. And
Yep.
I don't think that that's the case. I don't think that if you have everything automated, that you actually have a good machine learning system. You can have everything automated and it still be crap. And that's a
Great
point
point.
that my coworkers have highlighted. And so it could be correct from a software perspective, but correctness in software, traditional software, versus correctness in, I want to say, like machine learning systems, they're not always as simple or the same, if at that.
That's such a good point. It's so easy to think like, oh yeah, if we're automating everything, then we're doing the right thing. But there's so many pieces to this puzzle, and that's like what we wanted to get into today, right?
Yeah,
So let's go
yeah.
ahead and jump into that.
Yeah. So one thing I want to highlight at the very beginning is their definition of MLOps, which is interesting. A few people like have asked me that before. What is MLOps? And I have my sort of understanding of it. I've heard other people give definitions of it. It's a little bit different, but theirs is this. They say MLOps is a machine learning engineering culture and a practice. So notice those two things. It's a cultural and a practice that aims at unifying machine learning system development, so the dev and DevOps, and the machine learning system operation, so the ops part. So let's stop right there for a second and think about that. There's a cultural aspect of how the people working on it and building it, how they view it, how they interact with it. But then there's also practices. There's a set of like things that you do. And I think for a big one for Google is automation, right? That's one of the things that you do in a mature MLOps, framework. You have the ability to run everything from beginning to end in an automated way, so it's predictable, it's reliable, right? It's more controlled versus just something that's kind of done ad hoc by humans, which can be error prone. And so I think that, especially for their use cases, they're really thinking about it from that perspective of, DevOps. It's really like kind of a spin-off on DevOps.
Yeah, exactly. I think that's a great point. But let's like look at the other side of it, because I think that we've talked about DevOps versus MLOps a lot. And at the risk of beating a dead horse, we maybe don't need to talk about it much more. If you want to check out more on these subjects, we have 2 meetups on them and a coffee session on it. Or actually,
Yep.
2 coffee sessions on it. So, and we'll probably have another meetup on it before the end of the year, just because it is something that is top of mind for everyone. But for the sake of this coffee session, let's talk a little bit more about the idea of the pipelines that they set up and how they
Yeah.
architected them.
Even before we get into that, though, we need to think about how their view on machine learning system development, right? That's that development part of this, because according to Google, their view on the machine learning lifecycle, like I said, is that it's still largely experimental. So, in summary, they believe that there's this experimentation and development stage. Then you have this continuous training stage as you're introducing new changes, whether it's the data or the model, and then retraining that system and then redeploying it. And then that part of serving it, right, is how they kind of view these two categories. They have like this training component and the serving component, and they argue that a lot of focus has been done on just the training part. A lot of focus there. There's a lot of companies that are thinking about that, but they're also thinking about some of those preliminary steps, like the data itself, and automating some of those components, from data extraction to data feature engineering to the validation of that. So they include that in their view of system development. It's not just the model or the training part, it's also what comes prior to that. And so for them, they look at the focus of MLOps as developing reliable and repeatable, or at least for the first component of training, right? Reliable and repeatable training. So they want you to have an automated end-to-end pipeline for that first component of training. And again, this could usually entail, 2 sorts of like fields. You have like the data development, right? You're trying out new sources of data, new types of signal. You're engineering them in new ways to combine them to create new inputs for the model. Or you have a new, entirely fresh data set, right? Let's say if your system is a live system and needs to update regularly, the world has changed. So now you need to update, your model with the latest state of the world. Maybe you need to do that in actually a continuous way. And then of course there's model development. So, you're trying to find the right hyperparameters, you're trying new architectures. And so when they think of system development, they're looking at both of those components. Does that make sense? There's the data and the model and the training part as largely experimental.
And there's one thing that I wanted to ask you about. They have on the diagram in this article how they're kind of, I guess they're keeping version control with the metadata. Is that what I understood?
I think they're just thinking about actually gathering metadata on like, from example, like the run itself. If you have like an entire pipeline run, having something outside of that, like a metadata, database that is keeping track of, who started that run, how long did it run for, what resources were used, and also what data parameters, what model parameters were used. I'm thinking something along those lines is how I interpreted it.
Yeah, because that's something to like be able to go back and reproduce these results that you're getting and see what is happening. Some kind of check on that needs to be there, right? And
Yeah.
I know it's something that has come up a bunch in the community, is this like, okay, how can we assure reproducibility? How can we show like provenance of our data, of our models, all of that? And so they're going with like the metadata style of doing it, which I think, if I'm not mistaken, that's also what DVC is doing. And
I think DVC, maybe, but I thought they were more focused on like the data itself, versioning around the data itself, so kind of treating data like similarly to how you would treat, a source control system or a source repository. So having the ability to, like have provenance, lineage on the changes that were made. I think that's one thing that they're thinking about. But even here in this paper, Google is talking about that as well. They're talking about actually the link between that stage, the actual, data generation, feature extraction, all those things, that link between the artifact that is produced at the end of that and the artifact that is produced after model training. Like they actually talk about the link between those two things. So maybe we should kind of start walking through what they look at, how they understand reliable and repeatable training, right? So,
Exactly.
Okay, one thing is they say that you should typically start with like some development data set, right? And what you want to do is create an orchestrated experiment. Notice how it's not an orchestrated training run, but like the entire experiment is orchestrated together. So think of it as like one single thing. And what that ends up producing is source code, meaning you have code to extract the features, engineer the features, even maybe go into the model and then train it, right? And the goal, I guess, from their perspective is to be able to change only configuration. So just have the same sort of code, but be able to change certain parameters on that code. So for example, maybe the data that you're using, like which features you want to include in this experimental run, which which transformations, which sources, maybe you want to only try a subset of those features, right? But also being able to change the model parameters themselves, things that are specific to that, like the architecture or something along those lines, the learning rate, things like that. But also things like resources, like how many resources you're going to use for that run. So they look at it as having this system where you only need to change some parameters. So it really encourages reusability, which is a huge thing, and that's what they're trying to achieve with this is something that's repeatable and reliable. So does that make sense? You're starting off with this sort of like orchestrated experiment that only is changed by some configuration.
Yeah, and I guess my biggest question on this is they're doing this, they're talking about this whole holistic point of view where you just change these parameters. That's for one model, or could this potentially be for various models?
I think it could even be for a suite of models, but just, think of it because a model could be an ensemble, right? Like one algorithm could actually be a few different algorithms, right? That actually produce, let's say, some predictions. And then you have an algorithm to combine them. And then you have another algorithm to even like prioritize that even more. So there's like, again, it could mean one thing or an entire system. And I think if you think about it at a system level, then that's probably like the highest level of granularity that you should focus on. But
so
yeah, go ahead.
I might be putting you on the spot right now, but I know you've been looking at architecting a lot of different things lately.
Yeah.
Can you give me an example of like this architected, just like a kind of overview of how someone would architect something like this?
Yeah. So, okay. So let's say your model is an entire repository, right? So I'm thinking it's like you have a few directories, And then at the root of that directory, you have the requirements file, you have a README, and then within that, you have different folders that contain different parts of the source code, right? It's typically how I see, these model repos organized. And so if you have that connected to a CI/CD system, like let's say Jenkins or GitLab or GitHub Actions, then what you're going to be able to do is when you make a change to that code base, you're going to be able to run some automated things. For example, run some automated tests, and then even maybe automated deployment. And if all of the, like, for example, I'm thinking, let's say if you're using something like Kubeflow, which is again, I feel like this system really works nicely with that. If you have a system like Kubeflow, let's say you have one component of that pipeline that actually lives in this repo that is around feature generation. So you have a section of this repo that is connecting to various sources, maybe different APIs, pulls that in, processes it, and then gets it in a format ready for the model to consume. That could be one pipeline itself that is then componentized or containerized via Kubeflow pipelines. And that's like one thing that exists in the repo. Again, still the same place. So you still have that same CI/CD all in the same place. Then you have another component that is for the training itself. So it takes those inputs, it trains on it, maybe does some early stopping within a validation set. And then that's another component. You can containerize that thing, and that's another thing that exists in the same place. And then you could even have within it, let's say if you're using KF serving, another component that loads a train model, maybe from S3 or GCS, takes some input, whether it's typically going to be live input, maybe batch. You have a batch model, and then it's going to make some predictions, and you could have that as its own component as well. Its own, one way to think about it is it's one script, but from like this Kubeflow perspective, it's actually like a sequence of steps that is containerized together. So remember, we talked about containers. What it is, it's like little box, right? That has everything you need. And so they're thinking, imagine if you had like a one repo where each of these components are containerized in that repo. And if you have CI/CD built in, let's say through GitLab or Jenkins, then every time you make a change to that system, it gets checked in to the source repository. So you have versioning. You can know who made what push, who made that commit at what time. Are there different variations of this branch or whatever? And then you could even have automated deployment where after it's pushed, you maybe have a manual button that you click, say deploy to prod, or deploy to stage, deploy to dev environment. So they're kind of like, that's one example of I could think of where you have an experiment being one thing that you could run all together. And as you make changes to it, all you have is essentially like maybe a parameterized component that you could just pass in different parameters at each one of those component steps, right? Like the feature steps, the training steps, the serving steps. And one way to do that that I've seen a lot is like using a YAML file where you have a different section for each set of parameters, and then you load that in and then pass it in as arguments. But yeah, does that make some sense? You want me to break some of that down? I can't hear you. You put it on mute.
I see what you're saying completely. And I want to go into at some point this idea of why the way that we are looking at it right now lends itself so nicely to Kubeflow, and what other ways to look at it would be that maybe aren't the Kubeflow way of looking at it. So
there's other pipelines, pipeline systems or frameworks out there. Airflow's another one. You have Daxter is another up and coming one, and I'm sure there's even more that are going to come out, and others that I'm not aware of. But yeah, if you can basically, if you could find a way to run that code in a container, and then like kind of have different components also be containers. And when I say when I'm saying containers, I'm assuming that ultimately that code is running on some image. And that image could be tagged. There's some version control on that. And you could do that for each section of the pipeline, like the data part, the training part, the serving part. And that could be done with other pipelining systems. You could have all of that in one place. With Airflow, you could have a DAG that runs in, at each, operation in that DAG, a different image, that's maybe even if it's one model. Again, going back to this example of like a model repo where everything lives, and each of those different components is a container that is built and tested in your CI/CD system. Then you could just pass in that image tag in Airflow, and it runs those sequence of events. And you could do that with a lot of different tools. But I think that Kubeflow is working hard to integrate it. And again, Kubeflow is an ecosystem of tools. It's not just a pipelining tool. There's a serving tool, right? There's now they're even thinking about, this collaboration with the feature store. And so it's more than just a pipelining tool. And I think you could do this in, I'm sure even like you doing just pure Kubernetes if you really wanted to. Or maybe if you just want to stick to something cloud native like Argo, which actually Kubeflow uses in the backend. Mm-hmm. So there's lots of options, I think.
Just depends on how difficult you want to make life.
Yeah, or what tools you're already using. That's a factor in decision making, right? Like if my whole team is using this tool, is there any way that we can apply that to this? And maybe for better or for worse, teams do that because maybe you're making certain tools do things that they weren't really built to do. Like I would argue that Airflow wasn't really built for some of these long running training jobs, rather more of the ETL sort of data engineering side of things. So maybe that's like one of the I guess trade-offs there, But so this leads nicely into go ahead, Eric.
I was just gonna mention that the way that you set that up, there's not so much of a difference between the traditional software development and like what you set up and that kind of how you architected things.
I think still there's some differences because, again, we talked about this like at length before, but that data component, it requires its own set of like things that, like right here, you can containerize that feature extraction and generation step. But if you want to add, if there's different sources there, or there's different ways to engineer it, you still have to rebuild everything and kind of, redo that. None of that is still going to be automated. You still need human intervention and decision making. That's why even at the beginning of going to this paper, they talk about as data analysis is still largely like a manual thing. You need to like play around with, like, again, this is research, which is what Charles Martin was, kind of getting across where, there's still a lot of like, you don't even know what's a good source of data yet. So, but, you may need some room to be able to experiment with things, I would say more so than you have a need to even automate it yet. Like you mentioned, kind of automation is like the sugar on top of something. It's only done once you have a good thing. I don't know, where'd you go? You good?
Yeah, I'm here. Hold on a sec. I was trying to get.
Oh, good. So yeah, I think maybe we can keep going. Kind of like some of these things may flesh itself out a little bit more. But yeah, going back to their view of how do you create reliable and repeatable training. So you start with some development data sets. You create an orchestrated experiment that produces source code at the end of that, and then similar to any software system, which is what you're saying, you set up CI and CD, which we're going to kind of break down a little bit more again, to build all these components. You run automated tests on that. Maybe you tag it, you create different versions of that, and then you store those generated artifacts in an artifact store, like a repo, GitHub repo. And then you have also the choice to deploy those artifacts to a target environment. Maybe you want to keep that in the dev environment. Maybe you have a stage environment, prod environment. And so what you typically have at this stage from their perspective is you have compiled packages, right? And you also have container images. You have like a container that you could run somewhere. And that's like the next component. And then once you have that, they think about it as the pipeline is ready. You could run that pipeline. So you could do this continuously. For example, after that pipeline is deployed to a production environment, it's going to be executed automatically and repetitively to produce a trained model that is stored in some central model registry. So notice the difference. In the first part, you're producing the artifact, the output of that is source code, versus once you have that source code ready, the output of running that source code, that pipeline, is now a trained model. You have a model artifact. And so one thing that they try to really, kind of impress upon or like kind of get across as like important is that this pipeline should be able to run now on a schedule if you wanted to. Maybe you wanted to run with some sort of regularity, or you could run it based on some sort of trigger, some external event that's causing something to happen. So certain events maybe that you need to have configured for your business domain, right? Let's say you get new data, or even, we talked about this before, we'll dive into this, is if you have concept drift, right? So there's a performance drop in the prod model. That's an event that would trigger this entire pipeline to run again and produce a new trained artifact. But what they like here is that there's a link between the model artifact and then the pipeline. And they make a very important point to say that it should never be severed. You should never separate, that pipeline artifact from the model artifact, because they're very closely related, and you should have them in sort of a similar, environment where you could run each one end to end and make changes from beginning to end. And so,
there's something also that you had mentioned and highlighted, which are the metrics here and how key 100%. They are. And this idea of the lineage tracking. Can you talk about that a little bit?
Yeah. So, if you have a link between the pipeline artifact and then the model artifact, what you have right there is you can know what pipeline trained them. I can know what version of this pipeline actually produced this artifact that we're seeing now. What data was extracted, because again, that part has been containerized, at least the source code for that, not the data itself. And it's also, you can know how it was validated, how was it prepared, what was the training configuration, and how was it evaluated. So you have all of that history there, that lineage, and you could track it. So if you start developing some metrics around that process, you now can measure and quantify how good, how bad, start maybe relating it to some important KPIs or business metrics, and start, having doing some science on that component. And I think maybe this is something where you need this more so in machine learning than you do in typical software development. This research, it's a lot of research. It's about experimentation. And so at this stage, if you're developing metrics, you could really have a nice high overview of everything. Who trained it? How was it extracted? How was it evaluated?
Perfect. So let's move on now to the ops side and how that plays into all of this, because we have the infrastructure, we have the deployment. They talk a lot about this, and I'd love to hear your take on that, what they were saying in the paper or the article.
Yeah. So they think that, there's these sort of two sides of it, development and then the operations, right? Machine learning system development and then machine learning system operations. And operations typically involves the infrastructure itself, that serving pipeline that you're going to build, or the prediction service, right? But then there's also the release of that, right? So again, in their view, you're starting from some source repository and some model registry. And then what you do is you run your model deployment pipeline using CI and CD, continuous integration and continuous delivery. So you build your prediction service, you run automated tests on it, and then you deploy it to your target environment. Very similar to the pipeline artifact that you produce, and then the model pipeline that you produce, or model artifact that you produce. So, for example, at this point, it's very important to add additional tests, right? You're thinking about, maybe should we canary this deployment, right? Should I release a subset of it to a small, or should I have a different version of this model released to a subset of users? Maybe we need to do a silent deployment. Maybe we need feature flags. Maybe we need to do some A/B testing here. At the end of the day, what you need to do is you need to get some data on the traffic, how people are actually using this model, and use that to make decisions around the prediction service. And I guess one of their arguments is that if you have that in an automated way, you can kind of focus more on that component, on the ability to know what's the best way to actually deploy this.
So now,
so far so good.
Yeah, that's awesome. And the question came up in my mind is, how is this different, what you're talking about there, to what Elle was saying with CML?
So yeah, that's a good question. So my understanding of CML is that you're treating a training experiment as actually a version of the code base. So the parameters are going to be baked into the code base, and then you're going to run it. When I make a merge request, I'm opening up a different version or a different type of experiment, and I'm going to run instead of thinking about it as a different version of the code base, it's a different version of a different experiment, and running that experiment using the same sort of system that the source code lives in. So taking advantage of GitLab runners maybe to run certain training jobs. And what they offer is a cool set of functions which they make available through an image. So you could actually point to that image, and then when you run your script in that image, you can use some of those functions. So print the output and make it into a human readable report. So I don't think that these two are actually any different. It's maybe this is something you could add on top of that. If you're going to be running this, is how I see it. Maybe for the reporting component, But also, if you want to actually take advantage of, your current source control repository system, whatever, I don't know what the wording for that is, but if you want to like leverage that and have it all in the same place, that's one way to do it. But I think it's a little bit different from kind of what they're trying to get out, but there is definitely some overlap there. I get why you thought about that.
So, well, let's talk about this idea that in the Google article, it talks about how you have CI, CD, and then you have like the CT that they call it, which is a new one. They're introducing that into the vocabulary, the lexicon of our language, right? And so let's just talk about each one of those. I think we probably understand.
Even before we get to that, sorry, I know I don't want to belabor some of these points.
I'm getting excited and jumping ahead, and you're like, "Hey, good, man, slow down."
But going back to this this automated pipeline, right? This is what the article really is kind of talking about, and then continuous training. Why would you want to do that, automate it end to end? Well, let's say, for example, you have a live system, right? A live production system. Your model's in production. You're serving your users. So you get some live data, you run your live production serving infrastructure to make predictions, but then you could do some things like add explainability there. So that's another thing that they're trying to incorporate, is the ability to understand what it's doing while it's actually in production. So you could use, things like SHAP scores, or I know there's some tools around with Alibi. So maybe like for natural language processing models, having some insights into what it's doing, what it's learning. But you also want to evaluate the performance of that live model, and then you want to monitor it. So another reason to even have all of this automated is, let's say you're at that stage where you're capturing your performance and you have event logs, right? You're storing all of that. So back to that ML metadata point, you see that there's data drift. Now you should run everything again. You should run the data extraction, the feature engineering, right? So you can use that latest source. Then you want to retrain on that, and then you want to redeploy. So they look at it as, let's automate all that. Let's have that kind of like all be kind of one system, I guess, is one way to think about it. So that's going back to this idea of like, why should you automate that? Is that that can be, first off, they stress a lot of importance on, having the need to constantly retrain your model, which doesn't apply to a lot of use cases, which is something that we could talk about. But if the properties of your data are changing at all over time, then you want to keep a close watch to that production data and start thinking about things like, is this particular target class shifting? Is this feature distribution changing? And for some business domains, that's like really what they're dealing with, a changing world. So having this automated actually is much more attractive. I feel like, if that's like your use case, right? You have everything in one system, one place where you could run everything end to end. Again, they want to keep the experimentation and the serving environments really close together, so that you can make a quick change and get back to that new model in production after you recognize the need to rerun everything again. Does that make sense? Like the ability to have everything automated, not just like, okay, we're noticing concept drift. Let's now run another feature generation job and then separate from the model training job. They're thinking about, let's have it all as like one suite of jobs that we do, I guess, is one way to think about it.
Well, and it's interesting you mentioned this, because I remember talking to Shubi Jain, shout out to him. He was telling us how SurveyMonkey was doing this. And I asked him about, hey, can you guys just automatically retrain models and go through this process? And what he said is they had the ability. He said he thought it was important to have that ability, but they didn't use it that much. So he was like, yes, we can, but in my mind, it's not that used. And I'm paraphrasing like a mofo here. You can go back and watch the video where he talks about that, because I think he makes some really interesting points on the whole idea of automation and their view on it. And I think that's something that we're really trying to hammer home here, that if you're at like maturity level 0, don't get down on yourself, because it might just be your use case, and there is not a need. It's not like it's a specific need like in software engineering where, hey, let's automate everything. There are use cases in machine learning, because it is this experimentation and more scientific, right? It's like data science. You do not need to automate everything, because you may miss out on parts also.
Yeah, no, it just caused a lot of overhead and added complexity, and that may not be, you're again from a cost perspective, from a culture perspective. I think there's multiple ways to be why this wouldn't fit your use case. And I know even in my own company at Benevolent, again, automating everything is actually just doesn't make sense. We're still trying to find the right answers. We're trying to see what works. Again, I hate to belabor this, but Charles Martin kind of brought that up, where we're still trying to figure things out. We're trying to see what works, and once we know what works, then we should automate things, right? But maybe prematurely doing that is like, again, over engineering, which is, I think, something that engineers need to be particularly cautious of, for themselves. That I'm not over engineering the solution, because again, you need data science is I think largely a scientific endeavor, but it also involves so much engineering. So I understand, both needs. But continuing with this, let's say you have your live system, right? You're capturing your performance data in some log store, right? You have the ability to know whether or not concept drift is happening or not happening, or whether, the changes that you make to your model, how it affects your users. But at this stage, what you have is model provenance, right? You have the ability to track what's going on. You have lineage, and this can be maintained, right? You can evaluate your online model using your model's offline performance as a baseline, which is super important. Oftentimes, if your ML system can't be a basic heuristic or a baseline, you shouldn't be building a machine learning system. Like, machine learning is not going to help your problem. If it can't beat like some dumb example or some dumb baseline, like a super simple heuristic, then an automated system or model is not really going to do that well. And so I think what they're trying to get at is that using a baseline or some offline performance gives you the ability to compare against production data or production model and quickly identify where these sorts of things are happening. And so the idea here is, what they're trying to get at is that, the data science team shouldn't like deploy a model and then just leave. They should actually still be involved in this process. They should be able to pull up the training pipeline and produce that run that caused that model drift, and be able to do further analysis to figure out what's going on. Have the ability to inspect some of those things, and then again still understand what's going on with your live model. It doesn't stop at deployment, right? It's like a lot of people have been saying that the hard part actually begins once you deploy it. It's in the real world, right? This is where you actually start learning about your model in some cases. And again, this may differ for your company and what your use case is, but I think what they're assuming here is that this is particularly important to you. You have a changing world, and you need your system to adapt to that changing world, in particular your machine learning system to change and adapt to that world, not just your software system. It's more than that. There's the data, there's the randomness and the learning algorithms, there's the not knowing the right answer. Let's say you're predicting next quarter's revenue. You won't know if those are the right answers of your live model until next quarter. So these things, for them, make it, when you automate all that, you make it much more reliable, you make it much more reproducible, you mitigate the human error and things of that nature. And I would argue, when you do automate things, again, we already brought up the point why it actually isn't always good to automate, but when you do automate and do it right, what it does is it actually allows you to focus on the fun stuff, to do the important things, to actually think about how to improve the system and learn from it. And I think that's part of what MLOps is really about. We should be, we engineer the shit out of these systems to do what? to do machine learning well, to create business value for users, right? You don't automate just for the sake of automation, right? You don't build just for the sake of build. You have to be focused on solving a particular problem. And I think, if you're dealing with a changing world and concept drift, then you need to continuously retrain or rerun your whole sequence of events, then this may really help.
Yeah, it reminds me of the blog post that we just put out on who owns it. Was a thread in Slack, right? And it was so good that we just created it into a blog post, and it was a lot of people chiming in on who owns the problem once the model's out there. Like, and I think the way that we put it is like, you build it, you own it, or you run it. You build it, you run it. That mentality is very hard to do in machine learning because there's so many people that are involved. And there does need to be a bit of ownership for the data scientist, but once it's out there and it's like that day 2 operations, and if something fails, who's getting the call at 2 a.m.? Right. And so that's something that we've talked about. We kind of addressed, and I'll put a link to that in
that's a great point, that it actually enables more ownership of the pipeline. And I think actually, it might be Tecton that made, I think from their article in the past I read about like data ops or MLOps, they make that point that, you know, this gives you more ownership of the process if you don't have to worry about some of those things. Like if you free a scientist, a data scientist, up to just, you know, focus on the machine learning, maybe they may have more, you know, more incentive to take ownership of it versus like, oh man, it's deployment. That's, I don't know anything about that. That's super complicated. I don't know about canary deployments. I don't know how to, you know, set up feature flags and things like that. So I'm not gonna. That's a lot to deal with. I'm already dealing with machine learning. It's this vast field of complicated stuff. You know, I can only know so much. But if you make it easy for them, then it may reduce the barrier to entry.
All right, Bam Bam, where are we going now?
So I think what we're going to close with, right, is just, you know, these three terms that they bring up a lot in this article: continuous integration, continuous delivery, and continuous training. Let's start with continuous integration. You with me? You ready? Yeah. So let's start with continuous integration. So taking a Wikipedia definition, it's when you're merging multiple copies or variations of some mainline code base. So going back to the example of a model repository, different versions of that code base. And what you're doing is you're branching out, making a different version of it, making changes to it, and then reintegrating that back into the mainline code base. So a lot of developers are familiar with this, right? You know, git commit, you git checkout B branch, create some branch, make some changes on that branch, and then, you know, commit those changes and then push those changes and then merge it into master, maybe after you've done some code review. And that whole process of, you know, a team working on one thing, but working on different aspects of that thing together and doing it continuously. And the basic gist is you're going to take some copy of the code, do some stuff to it, push it back to the mainline or master branch. And you want to do this continuously, because one thing you want to avoid is integration hell, as they say, where you have some guy that worked on this branch for like a year and now merges it, and then there's just a million merge conflicts, and now you have to add all those changes. And so to avoid that, you want to make small changes frequently, right? And this is a good practice that I'd recommend for any data scientist: is don't wait to the end of the day to make a commit or push. Little by little, or I fixed this bug, commit, push. Added this feature, commit, push. And what that does is it gives you one, for me, if I'm looking at it, reviewing it, I could actually be like, oh, he did this, he did that, she did this, she did that. And I understand the story behind what's going on. And when you have that with machine learning, that's incredibly helpful, especially if you're collaborating across a big team, right? And this is how typically, you know, like, you know, open source projects work, is you have to work with a lot of different people. So how does that, you know, cohesion happen? Well, part of it is being able to continuously like a key component of that is being able to integrate continuously the changes that each person is making. Does that make sense?
Does to me, man. Sorry, I'm on mute all the time, and good. You catch me off guard. So
oh, good. But I'll keep going. But, you know, when at this stage, what you're doing is when you make that change and push it, you're going to validate it, see is it correct, and you're going to test it. So this is where you're going to run your suite of unit tests, integration tests, maybe some acceptance tests, maybe some contract tests. You're going to validate in a machine learning system, not just the code, but the data, the sources, maybe any schemas that are related to that, and then the model itself, maybe the model configuration. And so I think this is one thing that they actually think is a big part of MLOps, is being able to do this with the machine learning system, continuously integrate.
Yeah, that's huge. And then they introduced the continuous training, which is like the new word, the new.
Even before that, you got to go to the CD, continuous delivery.
Oh, we didn't. Right?
Yeah.
Right.
All good.
I keep jumping ahead, man. I don't know what's going on with me today.
It's all good. You're excited. You're passionate. He's passionate about continuous training. He wants to get to it. But all right, before we get to that,
I want to talk about that.
Continuous delivery. You want to be able to release at any time. Okay, and you want to do this in such a way that you're actually increasing speed and increasing the frequency of release. And what that does in a system is it reduces risk, right? Because you're not like, you know, risking big changes, breaking things, but you're also mitigating costs, right? If you redeploy some system and there's a problem, you're wasting resources on that, you know? And so you want to minimize that by continuously checking the correctness of that, or if it makes sense. And it also just saves time. So usually this is not going to be like a single software package or some service, but a system. So think with Google, it's a machine learning training pipeline. And what you're going to be doing in continuous delivery is automatically deploying that. And that's it. Like, again, continuous integration, continuously integrating it, continuous delivery, continuously releasing. So let's say deploying a production model, a prediction service. And that's CI/CD. So now with that in mind, what's continuous training? So according to what the article says is automatically retraining and serving the models. So the biggest use case is that when the individual features may start to drift. And this could be actually a bug in your system, something is wrong, or it could be perfectly normal behavior, meaning this is, the world has changed and now the model needs to be retrained. So let's say you have shifts in people's preferences. Maybe there's a marketing campaign or something, right? That behavior changes. Maybe you have competitor moves, you're keeping track of what other people are doing in the space. If you have the weather changes all the time, right? It's an evolving system. The news, right? News articles and what's going on in the world. Or even people changing location and time, different devices. So if your world is changing, then you need to, in some ways, retrain, address that change, and then make sure that your model is up to date, that it's not stale. You want to have a fresh model. That's a big component in MLOps is model freshness. Does that make sense so far about what it is? You're automatically retraining and serving models. And a use case for doing continuous training is when the features start to drift.
Yeah, completely.
So going back to this point about, continuous training and model drift, if the world that you're working with is changing over time, then you need to keep the data scientists and engineers working on that model instead of immediately going on to some next project, because that, again, monitoring is not just about software, like making sure that there's uptime, because your model could be up and just, serving trash predictions of sort, right? And so I think what we're going to kind of leave with and hopefully bring up, we're going to continue next time, is concept drift and continuous training. I think there's a lot to talk about here. There's been a lot of side conversation in the MLOps community about, should we retrain? If you're retraining too much, is that bad? Can you retrain too much? How do you retrain? How do you assess concept drift? And I think that's an assumption that this article is making. They don't really talk. I mean, they talk about parts of that, but they're not really. Again, that's like I think a need that continuous training is trying to meet. Does that make sense? They're trying to meet that need to, if this happens, if your world is changing, how does your machine learning system adapt to that changing world?
Yeah, but exactly. And it's like, wait, let's take a step back. And how can we know if this is happening first? Let's see, because it is not a trivial thing to figure out this monitoring piece. We've had 2 separate meetups on monitoring, and I think one that really struck home was from Lena when she came on, and she talked about, like, I think it was like she found 30 different ways that she could have bugs enter into her like monitoring. And I'm not
surprised by that.
And you hear it all the time about just like these cases that go wrong where a model starts doing something that it shouldn't be doing and nobody realizes it, because it's really hard to tell. And you think, and so from this, again, from like the traditional software engineering perspective, you can see that everything's on, it's going, and you see the metrics and you see the logs and everything seems all right, but really the model maybe is just recommending the same thing over and over, or the model it's not doing what you trained it to do, and so you're encountering problems. And I think that's something really like interesting how this paper just kind of brushes over that part, because in my mind, and people who have watched this more than once, I always talk about this observability and the monitoring with models. The day 2 operations are huge for machine learning, because it's starting to be something that I feel like is more important every day. We've gotten past this whole like, all right, how do we deploy the models? How do we get them out? But then when they're out, like you said, this is when the fun happens, right? That's where the trouble actually starts and we get to see what's going on. So I think that's a great point to kind of end on and hit home.
Yeah, and I'll just add that, kind of what we brought up at the beginning is that this is like an assumption that they make about what MLOps should look like, and if that doesn't apply to you, if like, for example, let's say in my domain, where we're working primarily on prioritizing the human genome for causes of disease, that changes. Humans change, organisms evolve, but like not that frequently. And so you trying to automate retraining all the time may not make sense for me, but that doesn't mean that I don't have a mature MLOps system or a system that's reliable and reproducible. You could have that in all sorts of ways. One way I'm thinking about is, if you're not automating it, is there at least some documentation on that? Is there a way to reproduce that particular step? Have you documented what you did in that manual process? Maybe even some notes, and have the ability to distribute that so that other people have some idea of what's going on. And maybe that could be done through a dashboard, or I don't know. The idea, I think what the focus is just minimizing error. It's like a lot of this stuff is like covering our butts, right? Protecting ourselves from crashing and burning. And if you're not really worried about crashing and burning, if your system changing so much, then why do that just because this is what they say the maturity level 0 is? Like, oh, we're at 0 still. It's like, that's okay. There's ways around that, especially if you're you're largely focused on research. Automation may not make sense. And so again, I'm glad that you brought up that this doesn't mean that you're doing bad, or that your system is not mature, or you're not doing a good job, or you don't have a good model. It just means that you haven't automated everything, and that's okay. If it doesn't make sense. And I think that we need to highlight that there's other ways. It's not, automation is not like the end goal. If you're focused on speed of delivery and the velocity at which you deliver stuff and deploy stuff, like a software company, then that makes sense. But if you're not focused on that, if that's not your priority, then I think you could learn a lot from this paper about applying this, making things easier for you. But it's okay if that's not a priority for where you're at right now.
Yeah, I think we're going to need to petition to Google to change the naming structure on this. They're going to have to change it from maturity 0 to 2 or 3 to maturity red, blue, green. Because then you won't feel like you're behind. If you're at green, then you're green. If you're blue, whatever. That's how it can be. Like, that's a better way of looking at it, as not as like behind or ahead. So I think we've covered everything that we set out to cover for today. Any last notes that you want to say, Bam Bam?
Just that the next time we have this conversation, we're gonna kind of continue in this vein of continuous training and really diving into actually when that is actually necessary. Typically when model drift is in the picture, or your world is changing and you want a fresh model, and staleness is important and affects performance. But no, I just also want to highlight, if anyone's listening here and has a lot of experience with, thinking about what MLOps is and how to communicate that to your company and bring these practices into play, I would also love to hear from Google. I'm really curious, why such an emphasis on continuous training? I know that they know machine learning, man. They have a lot of machine learning solutions that work at scale, right? And so I trust them that this is something to really, think about, but I also don't feel like it needs to be just like that. I'm sure that there's other companies that are developing other standards. So again, just kind of feeding back off that, I would love to hear more from their side of things, what informed them. And I don't know if that's possible, man. Maybe we'll get someone from Google on here, but just another thought.
Yeah, we'll get them to come defend themselves.
No, I got no beef with Google.
No beef with Google. We're just making that real clear.
That's it. No beef with Google. We love Google. But yeah, I think that's it for today, my bro. And thank you for everyone who listened to this conversation. If there's anything that you want to comment on, please let us know. Reach out to me and Demetrios. And we hope you have a great rest of the day.
See y'all.
Peace.